Hi, folks. Thanks so much for joining our deep dive on Amazon EventBridge today. I'm really excited to be talking to you about EventBridge and going through a couple of use cases that we think will be helpful in showing you how to use the service and how to build your own applications using it. A lot of what I'll talk about today revolves around the concept of event-driven architectures. And we think this is really important because we've seen that once customers start using the design pattern, they love it. It makes their teams so much more agile. It makes it so much easier to build scalable, reliable, and resilient systems. So try to keep that context as we go through the rest of the slides and the demos today. Amazon EventBridge is an event bus service that makes it easy to ingest and process data from AWS services, your own applications, and from SaaS apps. It removes the friction of having to write point-to-point integrations between services, and it's fully managed. So we take care of all of the scaling, and you only pay for what you use. So you're charged for events that get published to your event bus. For the agenda today, we're going to be running through a couple of demos. I'll start off first with an overview of EventBridge and how that all works. From there, I'll jump into a demo of a simple event-driven application and how you can build one yourself. We'll then look at how to use API Gateway to receive webhooks from Stripe, a payment processing company, and then send those webhooks events to EventBridge. Lastly, we'll take a look at one of our partner integrations with Zendesk and show you how to really easily do sentiment analysis on a support ticket that's generated in Zendesk. So starting off with a high-level overview of the different parts of EventBridge and kind of how all of those work together. The first bit that we'll take a look at is an event source. And these can be any of 95 AWS services that we support on EventBridge, custom applications like the ones that you write yourself, or SaaS applications. For SaaS applications, we have a special resource called an event source. And these provide a logical connection between the partner's system and your AWS account without the need to provision or manage cross-account IAM roles or credentials. From there, the core of EventBridge are our event buses. If you're familiar with CloudWatch Events default event bus, this is exactly the same thing, except that you can create your own custom event buses, as well as an event bus dedicated to ingesting partner events. Once you have an event bus set up, you can then create rules and associate rules with that event bus. Rules allow you to match against values in the metadata or the payload of the events that are ingested and determine which events should get routed to each destination. So if you take a look here, on the left is an example of an event that enters into our system. In this case, it's a ticket created. So it comes from a particular partner, and it's got a payload with the ticket ID, the department in which the ticket was created, and the user associated with that. So on the right-hand side, here's an example of a rule that we might write. And this rule is looking at a particular partner, and it's a very basic rule. It just says any events that come from this partner should trigger this rule. So on the left-hand side, because we see that our event is from that same partner, this rule will get triggered. Making the rule a little bit more advanced, we can add the fact that we're looking either for the billing department or the fulfillment department. So if an event comes in and this one on our left has the billing department, we know that it'll match against this rule because the billing department is specified in the rule. And then here's an example of a ticket that won't actually match against this particular event, or sorry, a rule that won't match against this event. We can see that this rule is looking for the ticket resolved, but our event on the left-hand side is ticket created. So that's a bit of background on how rules work. We'll jump into that a lot more just now. Finally, once a rule is triggered, you can associate multiple targets with that rule. And targets are used to send that event to various AWS services. So you could do things like invoke a Lambda function, put a record on a Kinesis data stream or Firehose, start the execution of a step function workflow, or start an ECS or Fargate task. There are up to 17 different targets, and we're adding to those all the time. So lots of different places you can send your events. A quick note on limits. Our published public limits show that there's a limit of 400 TPS for the put events API, that's sending events to an event bus, and 750 invocations per second. We also limit the number of rules on each event bus and the number of event buses per account. I must stress that all of these limits can be increased. So 400 TPS especially is one that customers often run into as being a bit too low. And we have plenty of customers doing tens to hundreds of thousands of TPS with EventBridge. So if you have a use case that's going to need larger limits than the default ones here, please just submit a limit increase request. The other thing that we hear customers asking us a lot about is the difference between EventBridge and SNS. SNS is a great and popular pattern for creating event-driven applications. So how does EventBridge compare? I think that the three most important areas to take a look at are fan-out, filtering, and latency. So for fan-out, if you have a use case where you need to send an event to millions of different subscribers, then SNS is really well suited to that. EventBridge allows you to fan out to 5 targets per rule. And of course, you could add multiple rules, but the use case is not really, for EventBridge, is not really to fan out to thousands or even more than hundreds of targets per particular event. On the filtering side, EventBridge allows you to apply a rule against the entire body, the entire payload of an event. Whereas with SNS, you can only filter on the message attributes. Lastly, latency. On EventBridge, the median latency is 560 milliseconds in US East 1, whereas for SNS, it's 25 milliseconds. So if you have a use case that relies on very low latency processing of events, then you might find that SNS is slightly better suited to that. Okay, so we're now going to talk a little bit more about building a very simple event-driven application. You've probably seen some version of this slide before, and many of your applications are likely moving from monoliths to microservices. Monoliths are difficult to scale, both in terms of the throughput, as well as the teams that support them. If you have a big, complex system and you want to be able to effectively leverage dozens or hundreds of engineers to build features in parallel, you have to move to a microservices model. So if you've made the move to microservices, you've probably kind of seen this architecture before. This is a really standard synchronous API-based service. In the case when a client makes a request to the order service, it has to make a downstream request to the invoice service. And once it gets a successful response, it can respond back to the client with a success message, provide a confirmation number, and the customer, in this case, is happy. And that works really great if you've got a nice, simple system like this. But what happens when you start adding a couple of more services to this and other services that want to integrate with your order service? And there's nothing wrong with that. Having a lot of systems that are interested in that data is totally normal and expected. But what is problematic is that in an API-oriented design is that the order service needs to know about all of these other boxes. We talk a lot about how great microservices are because they are decoupled, but the order service still needs to know and locate each of these other endpoints for these services. It needs to understand how to make the appropriate API calls, what to do if one of those fails, and it needs to have appropriate retry logic and error handling, and all of that stuff baked in for each of these underlying services that it connects to. And that might be okay for 3 services, but again, over the longer term, you're going to want to add more and more systems that take data from this order service. And each time you have to do that, those downstream teams are beholden to the order service team to implement that for them. So now with event-driven applications, our architecture looks a little bit different, something like this. The order service here sends an event to EventBridge, which is configured with a set of rules that determine which downstream service gets a copy of each event. So there may be some targets that only care about certain types of events, or that only care about orders for a particular account, or maybe they want to hear about all events that are getting published by the order service. Either way, the router, in this case EventBridge, now takes care of the complexity of ensuring these events get propagated appropriately to each downstream service. So if another team comes along and decides that they want to consume some subset of the order services events, they can just add a new rule to EventBridge without having to wait on the order service team to make an update for them. So this allows all of these service teams to act more independently and move faster. I'm going to hop over now shortly to a demo of EventBridge and how you can actually build a service similar to this. So we're going to look at the order service and how to send events from a Lambda function, which is functioning as our order service, send those to EventBridge, and then from there, how to consume them as the forecasting service. So I'll switch over to my screen share now. And you can see here, I've got a Lambda function. It's very basic. It requires the AWS SDK with EventBridge. And we start out by creating the static order over here. In your version, this order might come from some other place, perhaps from an API request from a customer. But for our purposes, we're going to start simple and just hard code that order in here. So you can see the order's got an order number, it's got a product ID, a price, and then some details about a customer. From there, we then create the EventBridge client using the SDK that we've included above. And we say that we're using the region US East 1. Just a quick note, it is important to include this SDK and not to use the one built in with Lambda, because Lambda's current version doesn't yet support EventBridge. So make sure you include that SDK manually yourself. From there, we're going to go ahead and then construct the actual event itself. And EventBridge events have a particular envelope that we need to follow. So there are a couple of required fields. The one is the source. The next is the detail type, which just explains what this particular event is. The detail itself, and that'll contain our payload, and then the event bus that we want to send this to. So you can see here, we've got our order details up above. We're just including that in this detail section. That's our payload of our event. And then the function simply just puts out the response that we get after we send that event. So really simple and pretty basic. One of the things you'll notice here is that I've got the section to update the event bus name. So I'm first going to go and actually create an event bus for this particular service. I've created the API command already, or the CLI command already, but very simply I call the AWS events method, and I pass the create event bus action. I give it a name, and in this case we've called the event bus orders. I've also just included my profile so that it sorts out my credentials. So when I do that, you'll see that I get an event bus on back, and that means that my event bus has been created. So I can go back to my code here and go and update this with the event bus that we'll be using for this service. So we called it orders. Now that I've updated my Lambda function, I just need to package that up and send it back to Lambda so that we get the correct version. So I'll quickly run that command. That zips our function, and then we simply upload it to Lambda and update the function code. So if I head over to Lambda now, I'll see that my function is showing. I'll just do a quick refresh. And you can see we've got that event bus name of orders added here. So what we want to do quickly here while we're just in this in the Lambda section here is to double check that we've got all of our permissions set up correctly. You can see that because I'm calling Amazon EventBridge, I need to actually set up permissions for this Lambda function to do that. So the way that I do that, I've done it already, but I'll explain it quickly here, is to just scroll down to the execution role and view the order services role. So you can see here, I've attached a policy and added the Amazon EventBridge full access policy. So that'll allow my Lambda function to put events to the EventBridge event bus. So now that the function is set up, I can actually invoke the function and make sure that it's sending an event through to Amazon EventBridge. So there we go, invoking my Lambda function. And you'll see here, it's a little bit difficult to parse, but we got a response that we echoed out, which had 0 failed entries, and we got a particular ID for the entry that we sent through. So that means that the event has been sent to EventBridge, but because we don't have any rules added yet, that event gets dropped. Nothing happens with it. So if I go to my orders event bus in Amazon Event Bridge, we can see that there are no rules created. So what I'm going to do to just make sure that we're actually getting that event being sent through is to create a catch-all rule that sends my events to CloudWatch logs. So I'll call this catch-all, and it's for the invoice service or for the order service. Let's make it. And then I'm going to match against a very broad rule pattern. So here I'm saying all events that come into this event bus. So you can see the pattern that gets generated is saying anything that's an event with my account ID will match against this rule. We then head down to the target section, just quickly making sure that we've selected the correct event bus here. So I want the orders event bus, and then to the target section. So here we can choose CloudWatch logs, and we will put in order catch-all. So I go ahead and create my rule, and we can see that's being created. So if I now head over to CloudWatch logs and just do a quick refresh here, we have that log group for the catch-all. So I'll go back to my Lambda function and simply invoke that. So now what happens is my Lambda function runs. It calls the put events API call. We see that it successfully sent that event. And if I go back to my CloudWatch logs and refresh that, you can see that a new log's been added, and there is my event. So a couple of fields get added to the event automatically by the system, things like account, the time I didn't specify, so the system takes care of that, and the region. But my payload that we included, that has been added here, and we have the order service as the source and the detail type as new order. So that's great. We're receiving events on the event bus, and we can see them coming through. But now we want to do something a little bit more interesting with them. We want to send them to the forecasting function. So if I go back to Lambda, I have a forecasting function that I've set up here, and this is super basic. All it does is receives an event, it echoes that event out, and then it leaves all the hard work to someone else. Someone else can come and do the fancy forecasting function. Now, before I send an event and create a rule to send to this forecasting function, I go back to my Lambda code and I realize, I'm actually sending some customer information here that might be a little bit too sensitive to send to the forecasting service. It's not really needed by that service, and ideally I don't want customers' addresses floating all over the place. So what I'm actually going to do here when I create my rule is use an input transformation to ensure that I only send the relevant parts of the event to that forecasting service. So we'll go back to EventBridge and create a new rule. And we'll call this forecasting service. Tidy that up a bit. And we're going to match against a specific pattern. So in this case, we're actually looking for a pattern where we're not wanting to get all events sent to our forecasting service. Instead, we're actually looking for a subset. We actually only want events that are from the order service and that are the new order event. So the way we do that is by simply writing up a rule that matches that pattern. So we can check that out here by just copying this predefined text that I have. So all this says is look for the source of where it's the order service and the detail type that is new order. And I can save that. Now, you might be wondering, how do I make sure that I've actually got that rule correct? Like, how do I make sure that it's working correctly? Well, Amazon EventBridge provides an API endpoint called the test event pattern endpoint. And that allows you, I'll just put it out here, it allows you to pass an event pattern that you've created. So this is the event pattern that I've pasted into my rule over here. And then it allows you to provide an event. And you can see this section is actually just a copy of my event. So I had that event sent through to CloudWatch logs here. I can copy that and just paste it into this event section. So what I do now is I hit enter on that, and I get a response from this test event pattern endpoint that says true. So that means that the rule that I've, or the pattern that I've created there will actually match against this particular event. So a good way to make sure that the rule that you're creating actually has the correct pattern is to use that API endpoint to test it against the events that you're actually generating. So I now go down and I select my Lambda function as the target. So that is the forecasting service. And as I mentioned earlier, I want to configure the input so that I don't send the entire event, which is the matched events option here. I send just a subset of it. So to do that, EventBridge provides an input transformer that first lets me set an input path, and then from there to generate a template. So again, I've made a sample one here that I'll copy paste across, and I'll walk through those shortly. Okay, so our first line here is talking about sending out the fields in our event that we're actually interested in. So we talk about the order number field, and we map that to the details section of the event, and then the order number section. And if you go back here, you can see that the way that works is this is our event. We have the details section, and then as a subsection of that is the order number. And we do the same thing for price and for the product ID. So that just allows us to access those particular fields in the event JSON that comes in. The next part allows us to then construct the actual JSON that we'll send to the forecasting service. So here we just take those variables that we've used in the field above. If we wanted to, for some reason, rename those variables, we could do that. Those fields, we could do that here. So if instead the forecasting service expected something like order number, we could do that like this over here. So once I've added that input transformer, I'll create the rule, and that rule has been created. So what I'm now going to do is generate that event again. It'll match against our catch-all rule and be sent to our CloudWatch logs. But then we'll also get it to get sent to the forecasting service. And the forecasting service, remember, very simply just echoes out that event. So what we'd be hoping to see in the forecasting service is just a couple of those fields that we've specified coming through. So I'll go back and invoke my Lambda function. This calls the put events from our order service. We saw that earlier. That sends it to the event bus. The rule on the event bus matches against our particular rule. And if we go through to CloudWatch logs and take a look at that Lambda function, we'll see the event has started. So let's give it a few more seconds. There it is. So we have the order number, the product ID, and the price. So you can see we've gone from an event that had a whole bunch of additional information that we actually didn't really want to send to the forecasting service. We've removed that using an input transformer. Great, so I'll head back to my slides now. So as we saw, we created an order service, which was a very basic Lambda function. That emitted an event using the put events API call from the Amazon AWS SDK. That got sent to EventBridge. We had a rule, first of all, just to help us with some debugging that stored all events in CloudWatch logs. And then we created another rule, which had an input transformer on it and allowed us to send only a part of that event to the forecasting service. So that's a very basic example of building an event-driven app. If in the future we wanted to add the fulfillment service or the invoicing service, they could simply come along and create a new rule on that event bus and determine which events they're looking for using that rule and send it to a target that works for them. Great, so now we're going to step over to the next section, which is around handling webhooks. So a lot of customers have control over their applications. They can determine how they where they send those events that are being generated by the applications. But in some circumstance, you can't, and you have a third-party system that's sending you events. In this particular case, I'm using Stripe, which is a payments processing company, to receive events from new payment events from customers. So if someone signs up to my service, and in this case, we'll say it's a subscription service, whenever they start their subscription, Stripe sends me a webhook event for the invoice being created. So I now need to have some sort of a way of capturing that webhook. And the most common way to do that is through Amazon API Gateway. And from Amazon API Gateway, I actually want to send that event to EventBridge. And you can imagine that there may be a lot of different events that are coming from Stripe. So I might want to just put some of those through Kinesis Firehose into Amazon S3, just so that I have an audit trail and a log of all of the events that are being sent to me from Stripe. But I also, in this particular case, because this invoice is being created, I might want to generate an email to the customer to say, hey, your invoice has been generated. Here's some more details for you. So for that, I'll match against the invoice created events with a rule and send those to a Lambda function. So for this example, we're going to hop over again back to our browser, to our screen share, and I have the Stripe application here. So you can see in the webhook section, I have a webhook set up. I'll delete that quickly just so that we can start right from scratch. And Stripe allows me in my developer console to go and create a new webhook. I can specify which events I want to receive. So I might want all the invoicing events. I might want all of the customer events. So I've selected all of those. It's going to send me 29 events. But Stripe's looking for an endpoint URL to send those events to. So what I'm going to do now is head over to API Gateway and create a new API that's public facing on the internet for Stripe to send those events to. So I'll click Get Started here and create a very basic API. So we'll call this Stripe Webhooks and hit Create. I'll now add a resource, which is the webhook resource. And then from there, add a new method on that. So Stripe uses a post method to send webhooks. So I'm going to select post over here. So what I have now is an API with an endpoint and that can receive post requests. But when I receive that event, that webhook from Stripe, I want to actually send that to EventBridge. So the way I do that is by selecting AWS service as the integration type. I then choose my region. So I'm working in US East 1 at the moment. And I choose which service I want to send it to. So API Gateway still calls EventBridge CloudWatch Events, as EventBridge was previously based on CloudWatch Events. That's where the naming comes from. It uses the same API endpoints, and the same functionality that existed in CloudWatch Events still exists in EventBridge. So you'll use that on the drop-downs here. I'll select any method for the HTTP request. And then the action I want this to perform is the put events action. So now what you'll see is that API Gateway needs an execution role with which to use when calling our put events command or API command on Amazon EventBridge. So to set that up, I head over to IAM, and I've created a role already, but it's very easy for you to do so yourself. And then you simply attach the Amazon EventBridge full access policy to that role. So I've got that role here. I'll copy it and head back to API Gateway and paste in that particular role. So what I do now is save, and that sets up that post method for me. But I'm not quite finished in order to get those events to flow through to Amazon EventBridge. The next thing I have to do is just make a little bit of a tweak to the headers and to the template that's used to send the event from API Gateway to Amazon EventBridge. So if I go into HTTP headers, there's two headers that I need to configure in order to have EventBridge accept the request from API Gateway. The first is the XAMZ target. So I'll paste that in. And I've got to set that to the action that we're wanting API Gateway to perform, which in this case is put events. After that, I need to specify the content type. So Stripe send the request to API Gateway is application JSON, but what we need to send to EventBridge is slightly different from that. So let me show you that here. We use application/x-amz-json and the version that we're using there. So these are really critical to set in order to get API Gateway to use the correct headers when making a call to EventBridge. The next part that we need to look at is the mapping template. So if I head over to the Stripe documentation, you can see a little bit of detail here on what an invoice request from Stripe will look like. It's got an ID, it's got an object, it's got the account that it's related to, it's got a whole bunch of details about the customer. So there's a whole lot of information that Stripe's going to be sending through here. But the problem is that they're not going to do it using the envelope that EventBridge requires. So if I go back to that auto service that I covered earlier, this is kind of the structure that we need to send an event to EventBridge in. We have to have the source, the detail type, the event bus name, and then that Stripe webhook request can all go into the details section of the envelope. So to achieve this, we're going to do a bit of a transformation between API Gateway and EventBridge. To do that, I come in here and I click Add Mapping Template. And I'm saying that I want this template to apply whenever we receive an event from or a request on API Gateway that is of content type application JSON. I then go down to this section over here and define my mapping template. So I've created that already, but I'll walk through it quickly here. So this sets our input route. And then you can see I've constructed that envelope of the Amazon EventBridge event that we need. It has the outer entries, which has an array of entries. So you could batch a number of events. In this case, we're going to just send a single entry. That entry has a detailed type. And you can see what we're doing here is we're saying that we want the detailed type to match to the type field that gets sent through with the Stripe webhook request. We're hard coding the source to Stripe because we know that all the events that come to this endpoint are from Stripe. And then we specify the event bus name. So I've created an event bus already called Stripe Payments. Lastly, we set the detail section. Remember, that's our payload of the event to the actual entire event that we receive from Stripe. But just to make sure it all works correctly, we actually have to escape that JSON when we include it in here. So I'll hit save, and we now have API Gateway receiving an event from Stripe and sending that on to EventBridge in the particular structure that EventBridge needs. So the last thing I'll do here is just deploy this API, and that'll give me a URL that I can use for Stripe. So here is my URL. I'll copy all of that and then head back over to the Stripe dashboard. So I can now paste in my endpoint URL. I created that method, that was the webhook method. But as we set up earlier, here are all of the events that I've told Stripe that I want to receive. So I add that endpoint. Now, if Stripe were to send me any webhook events at this stage, they would go from API Gateway to Amazon EventBridge. But because I don't have any rules set up, I won't actually see those events and they'll get dropped. So like we did earlier, I'm going to head back to EventBridge and create a rule that catches all of the events from Stripe. That'll allow us to do some debugging and make sure that the events are coming through correctly. So I'll call that Stripe catch-all. And we're going to go for a ready broad pattern as we did earlier. And then we'll head down to the target section and choose CloudWatch log group. And we'll call this the Stripe catch-all. So if I head over to CloudWatch logs now and just refresh those, we've got this Stripe catch-all section over here. And at the moment, there's no logs in that particular log stream. So to generate an event from Stripe, I can go into their dashboard. I'm using the test dashboard here. And I can go into the subscription section and create a new subscription. So this allows me to select my customer. I've previously created a customer. I've also previously created a product. So I'll select that monthly plan that I've created. And it's got that particular customer's test payment details as well. So I'll hit the Start Subscription button. And what happens in the background now is Stripe sends a webhook request, and in this case, it might be multiple webhook requests to that endpoint that we'd specified in this webhook section over here. So what I expect is if I go to CloudWatch logs and I hit refresh here, we should have a couple new entries. And so if I just order those on time and go to the latest one here, we can see the most recent one that Stripe sent us was a subscription created event. I suspect if we go through these, We'll see a couple of other ones for the invoice created. So there's the invoice created. And you can see that the structure of the event that we received has these fields that we set in that mapping template in API Gateway. So the detail type matches against the type that Stripe sends through in their webhook. If I scroll down, you can see the type here is invoice created. So that's used right up at the top in our detail type section. We've then hard-coded the source to Stripe, and the details section over here contains all of the details, all of the data that Stripe sent in their webhook request to API Gateway. So this is super cool. We're now getting all of our events coming through from API Gateway directly to EventBridge. But I want to go back because logging all of our events in CloudWatch Logs is not exactly what we wanted to do. We first wanted to send those events to Kinesis Firehose so that they could get stored in S3 for auditing purposes. So I'll go back to my catch-all rule and edit that. And in my targets section, I'll remove that target of CloudWatch Logs and add a new target. I can put in Kinesis. Actually, I'm looking for a Firehose stream. And I've previously created a Firehose stream for this particular set of events. So what Kinesis Firehose will do is take all of the events sent from EventBridge and store them in an S3 bucket that I've set up previously. That way, if at any point in the future we need to do an audit of the events we received from Stripe, they're sitting in S3 for us to use. So I'll update that rule, and we're now sending all of the events from Stripe to that Kinesis Firehose. Okay, so the next thing that I want to do is run that Lambda function that sends the invoice to our customers. So I have a Lambda function here, and you can see that it's very basic. It simply outputs the event that it receives, so it logs that, and we've got that lovely to-do to send the invoice to a customer. So we could do something a lot more fancier here to generate a really nice looking PDF or email, but we're going to keep it simple for this case. So to match against this particular invoice created event, I go back to EventBridge and I create a new rule. I'll give this rule name the invoice rule, and we're wanting to match against a very specific pattern. So here we are looking for a source being Stripe, which we set all of our events to earlier. And we're looking for the invoice created detail type. So we want to ignore all other requests, all other webhook requests from Stripe, and simply focus on this invoice created one. So I hit save there. I make sure I'm on the correct event bus, and then I choose my invoice service Lambda function. So I'll go ahead and create that, and you can see that rule is now enabled. So if I head back to Stripe and I create a new subscription again, select the customer, choose the product, and create the subscription. We'll see again if we go back to our catch-all, or actually, sorry, we can't see it here because it's now being sent to Kinesis Firehose. So while I'm in this log group, I will go to my invoicing service. You can see that's got an entry that's just come through now. And if I expand that, you can see it echoed out the full details of that invoice created event that got sent from Stripe. So if I look into this text, I can see the detail type is invoice created. And this was echoed out by our invoicing service. So if I head back to my slides now, you can see that we have sent an event from Stripe when our invoice was created. That has gone to API Gateway. We've set up an API Gateway endpoint that will then send the event to Amazon EventBridge. It does that transformation to make sure that it's using the correct envelope that EventBridge expects. And we've added those headers so that the request from API Gateway to EventBridge actually is able to succeed and is called correctly. From there, we've created a rule that will store all of the events as an audit log into S3 using Amazon Kinesis Data Firehose. And then we've added another rule that takes our invoice created events and runs a Lambda function. So a really cool way to receive events from any application that's generating webhooks and send those over to EventBridge so that any team in your organization can start using those events for whatever needs that they have. Great, we're going to now hop into our last demo, which is around connecting Zendesk, tickets from Zendesk, which is a support ticketing tool, and doing sentiment analysis on those tickets. So the kind of use case for this is potentially you have tickets that are getting created in your company, and you want to understand which of those should be high priority. Potentially you have managers that should get involved with certain tickets. And you might say that, well, tickets that have negative sentiment, where a customer is clearly upset and angry, need to be prioritized. But to do that manually, you'd have to have someone sitting there and assessing the kind of sentiment of the ticket and then updating the priority of the ticket. So instead, what would be really cool is if we could use Amazon Comprehend, which does sentiment analysis, to automatically look at that ticket sentiment and update the ticket if it has negative sentiment. So how would we do this if we didn't have EventBridge? One of the ways of bridging the gap between Zendesk, our SaaS application, and our downstream microservices would be to do something like webhooks. And we saw that happening with Stripe. So we could get Zendesk to send events to Amazon API Gateway, and from there to a Lambda function, which then does the sentiment analysis. And that works okay, but we've seen that there's a bit of effort there in getting API Gateway to actually send those events to Amazon EventBridge. The other way that we could do it is by polling Zendesk's API. And this is a fairly common approach to getting data out of systems. Having a scheduled Lambda function run on a certain frequency and check the API, Zendesk's API, for any new tickets that have been created. And again, that works okay, but it's a fair amount for us to have to manage. We have to make sure that that poller keeps running. If the API changes, we have to handle that. We have to think about API authentication. So there's a fair amount of work there to just keep that infrastructure kind of going. So the question is there a better way? And I suspect you'll know the answer. We think that there is. So again, if I switch back to my screen share, you can see here that I'm on the Amazon EventBridge page, and we saw those concepts we talked about earlier, the event buses and the rules. But we have this third section here, which is partner event sources. So partner event sources allow us to go in and connect a third-party partner such as Zendesk and to start receiving events directly onto an event bus from those particular partners without the need to do any polling or to set up API gateway to receive webhooks. So I'm going to click on Zendesk, and you can see there's some more detail here about the actual integration, some of the use cases that I might be interested in. But right now, I actually just want to get this set up so that I start receiving events from Zendesk. So I click the Setup button, and there's 3 simple steps to do this. The first is that I have to copy my AWS account ID. So I do that, and then I head over to my Zendesk Admin Center. I've got that tab set up here, but there's an integrations page where I can start setting up the Amazon EventBridge connector. I'll click Connect. And then all I need to do is put in my AWS account ID that I copied from the previous step and choose which region I want my event source to be created and where I'm going to receive my events. I can also select the types of events. In this case, Zendesk only supports sending support tickets. So I'll hit Connect here. And what's happening in the background is Zendesk are sending a request to the EventBridge API to say, create partner event source. And what that does is creates a resource in Zendesk's account and makes that resource accessible to my account ID that I provided when I hit connect on that previous screen. So if I go back to my EventBridge console now to my partner event sources, you can see that I have an event source from Zendesk that is in my account or accessible to my account, and it's in the pending state. So at this point, Zendesk could start sending events to that event source, but because I haven't connected this to an event bus in my account, they won't actually flow through and I won't get charged for any of those events. So to make that actually work, I select the event source and associate it with an event bus. That allows me to specify any permissions that I might want and then create the event bus. So you can see that event source is now in the active state. And if I go to my event buses, I have an event bus here for the Zendesk event source. So from there, I now want to send events from Zendesk and trigger my Lambda function that does sentiment analysis. So if I go over to my Lambda function, I've set this up beforehand. I've given it access to Amazon Comprehend in the permissions section. And you can see the function over here. It's really basic. It takes in an event, which we receive from Zendesk. It just sets those out into a couple of variables. It then makes a request to Amazon Comprehend using the AWS SDK. And it says that it wants it to detect the sentiment of the comment that we received from Zendesk. If the comment is then determined as negative by Comprehend, we want to update Zendesk's ticket. We want to set the priority to urgent, and we want to add some tags to that to say that it needs priority support and that a manager is required. If the response that we get from Comprehend is not negative, then we'll set the ticket priority to low. So to update the ticket on Zendesk, we're having to call their API. And so that's handled in this update Zendesk section over here. So what I'll now do is, now that I've got this Lambda function working, is I'll go ahead and create a rule for that. So I go and select my Zendesk event bus and click the create rule button. So here I'm going to keep it really broad and match against any event that comes from Zendesk, but I could of course specify the type of event that I was looking for. So I might put in here that I'm actually just looking for the ticket created event, but for now we'll keep this simple and just make it a broad rule. I then go down and select my Zendesk sentiment analysis Lambda function and set that as the target. And so that rule has been created. And if I go back to my Lambda function and refresh this page, you'll see at the top that it's picked up that we actually have Zendesk acting as a trigger. You can pretty easily go in from Lambda and add various other triggers. You can see AWS services, and then any of those EventBridge partner event sources that you have created are accessible here as well. So if I had any of these other partners, I could very easily add them from Lambda as well. But we've got Zendesk set up, so there's no need for us to go and set that up again. So now what I'll do is head over to my Zendesk section and create a new ticket. And this might happen on your website somewhere by someone emailing in. There's various ways to create a ticket, but I'm just going to do it directly through Zendesk's dashboard. This is my ticket. And I'm going to say here, I'm really sad and disappointed in your service. It was bad. So I want to make sure that Amazon Comprehend picks this up as a negative ticket. So I'll submit that ticket. Whoops. Let's see what happened there. And you can see my ticket got created. So immediately that ticket has been set to urgent, and the tags manager required and priority support have been added. So what happened in the background, and it goes pretty quickly, is Zendesk sent a request to a ticket to EventBridge when the ticket was created. That matched against my rule that I'd been created, and then the rule sent that to my Lambda function. The Lambda function then did sentiment analysis on the ticket contents, determined that it was negative, and updated the tags over here. So really simple way to start receiving events from a SaaS partner and do interesting things with them using AWS services. If I head back to my slideshow, so hopefully you saw there is a better option. And if you're interested in getting your company added as a partner, you'll join a bunch of our partners that we've launched with. You can simply email eventbridge-partners@amazon.com. So that'll get you set up. We'll respond with some details on how to become a partner for EventBridge. Great. If you need any further information, we've got some resources out there. You can go and take a look at our product page. And after that, our documentation for EventBridge. And as I mentioned before, we have that eventbridge-partners@amazon.com email address. So if you're wanting to get in touch about becoming a partner, please get in touch and let us know. So hopefully that's given you a good overview of how you can start moving your own applications to become more event-driven. Instead of making API calls between all of your various microservices, you can use EventBridge to start putting events onto Event Bus and then have those downstream systems select the events that they're interested in. We've also shown you how to connect API Gateway so that if you have an upstream service that cannot call the put events API, you can instead simply give them an HTTP endpoint that they can send their events to, and then bring those events into EventBridge, where we take care of the delivery to all of the downstream services. And then finally, if you are using a partner, one of those 10 that we support so far, you can very easily hook them up without having to worry about API polling or managing webhooks and get those events directly into an EventBridge event bus. Great. I'll now be taking any questions, so please feel free to submit them into the chat and I can answer those from here.